On Earth, there are variety of soils, and they all exhibit different kinds of behavior. Properties of soils vary not only with the soil types, but also with the soil grain arrangement and moisture content in the soil. For example, we may safely assume that gravel and sand soils will behave differently than clays. But we cannot assume or say that all sands will behave alike or all clays will behave similarly. A loose sand will behave differently with the same sand if it is dense. Similarly, saturated clay will behave differently from the same clay in the dry state. So, to understand the behavior of soil, we try to evaluate its properties in terms of grain characteristics, arrangement of particles, and moisture content. Using these evaluated properties, we try to classify the soil into different categories. And properties of soil that help in the identification and classification of soil are called index properties. Index properties can be divided into two categories: soil grain properties and soil aggregate properties. Soil grain properties, as the name suggests, depend upon individual grains of soil. Properties in this category are mineralogical composition, specific gravity of solids, size and shape of grains. Most important properties of individual grains of soil are the particle size distribution and grain shape. Soil aggregate properties, these are dependent on soil mass as a whole. That is a huge amount of individual grains of soil put together. This represents a collective behavior of soil. These aggregate properties depend upon soil stress history, how the soil is formed, and soil's structure. These properties are of greater significance for the engineering practices. Most important aggregate property of the soil is its relative density. We will learn all these in coming videos. Thank you.